Rule-based customer segmentation in market research. We are learning to segment customers using rules based on real business data. Segmentation helps companies target the right customers and improve products or marketing. You will use real survey and behavioral data to design and analyze practical customer segments. By the end, you will have learned to define rules, apply them to data, and interpret actionable insights. Running the cell now. We import pandas to work with tabular customer data. We import numpy for numerical operations we may need. We import opaml to easily load real market research datasets. We import the warnings library to handle warnings during analysis. We ignore warnings to keep outputs clean and focused on insights. Running the cell now. Understanding the data used for rule-based segmentation. Market research data includes customer demographics, surveys, and behavior. Each row represents a person or customer with features like age, gender, and service usage. Beginners often forget to handle missing values or misinterpret text responses. Columns may be categorical, numerical, or text, each requiring different analysis techniques. Getting to know your data structure is essential before creating any rules. Running the cell now. We load a real customer satisfaction dataset from OpenML for analysis. This dataset gives us customer demographics and service features. We print the dataset dimensions to see how many records we have. We preview the first 3 customer records to understand the data. Running the cell now. The output shows the dataset contains 7,043 customer records with 20 features, including demographics and service details, which aligns with our lesson's focus on exploring data structure. Notably, the first few rows reveal a mix of categorical columns like gender and contract type, and numerical columns like monthly charges, illustrating the variety of data types we must handle. This overview is key to preparing for rule-based segmentation by highlighting important features and potential data nuances such as missing values indicated by no phone service. Look for features that might make sense as rules for segmenting customers. We want to know how many customers have churned compared to those who have not. Churn means the customer left the company, which is important to segment. We print the result for business insights on customer loss. Running the cell now. This output shows the distribution of customers who have churned versus those who have not, with 5,174 customers staying and 1,869 leaving. Noticing this imbalance is important because it highlights the need to consider class proportions when creating rules or models. It also reminds us to verify that the churn column is correctly categorized before segmentation. Practice: how might high churn in a segment change your business strategy? We check how many customers are in each contract category. Looking by contract type helps businesses design targeted offers. The counts let us see which contract types are most popular. Running the cell now. This output shows the number of customers for each contract type in the dataset, revealing that most customers, 3,875, have month-to-month contracts, while fewer have longer-term contracts like 2-year or 1-year agreements. Noticing these counts helps us understand customer distribution and informs how we might segment users based on contract duration in later rule-based segmentation steps. It also highlights the importance of examining categorical columns to ensure accurate segmentation rules. We create a new segment. Customers with less than 12 months are new, the rest are established. This rule will help us focus on differences between new and loyal users. Running the cell now. This output shows a new segment column categorizing customers based on their tenure. Those with less than 12 months are labeled new, and the rest are established. Notice how the segment aligns directly with the tenure values, highlighting a clear binary split. This simple rule-based segmentation helps in understanding customer stages before applying more complex analyses. Try adjusting the tenure cutoff to see how segment sizes change. Now we examine churn rate within each tenure-based segment. This tells us if new customers are more likely to churn than established ones. Running the cell now. This output shows the proportion of customers who churn or stay within each segment, highlighting that established customers tend to stay, about 82.5%, while nearly half of new customers churn. Notice the normalized rows, which make it easier to compare churn rates across segments regardless of size. This helps us understand segment behavior before building rules to target at-risk groups effectively. We load a real online retail behavioral dataset. The data include purchases made by customers, useful for rules based on behavior. We ensure the invoice date column is in the correct format. We print dimensions for a sense of the data size. We preview a few customer transactions with country info. Running the cell now. This output shows the dataset has over 500,000 rows and 8 columns, indicating a large sample of customer transactions. The preview highlights key columns like customer ID, invoice date, and country, which are crucial for segmentation based on customer behavior and demographics. Noticing the date-time format and presence of multiple rows per customer helps you understand the data's structure before applying any rule-based segmentation. We group customers by country to see which regions have the most unique buyers. This lets a business focus marketing on its largest markets. Running the cell now. This output shows the number of unique customers from each country, highlighting that the United Kingdom has the largest customer base by far. Notice the large difference in counts, which indicates that country-based segmentation will heavily depend on the UK data. Understanding these key columns and their distributions helps ensure segmentation rules are relevant and well-informed for each market. How would your promotion differ for each region? Discuss with a teammate. We calculate each customer's total purchase quantity. We define the top 10% as high value by using the 90th percentile. We identify customer IDs that qualify as high value. We label each row with its value segment for targeting premium offers. We show samples of customer value segmentations. Running the cell now. This output shows how customers are segmented based on their total purchase quantity, with each row representing unique transactions for selected customers. Notice that here, both customer IDs are labeled regular because their summed quantities did not exceed the 90th percentile threshold, illustrating the importance of aggregating data before applying segmentation rules. This step ensures that high-value customers are correctly identified for targeted marketing strategies. Businesses often segment by a combination of features. Here we combine tenure and contract type into a new rule-based segment column. New, month-to-month users are labeled at-risk new. Loyal users on 2-year contracts are loyal long-term. All others are set as other. We print the first 7 results to review the segmentation. Running the cell now. This output shows how the code classifies customers into segments based on tenure and contract type, creating a new segment 2's column. Notice how short tenure, month-to-month customers are labeled at-risk new, while long tenure, 2-year contract holders, not shown here, would be a loyal long-term, highlighting rule-based segmentation. This step illustrates how to translate raw demographic and behavior data into meaningful categories for targeted analysis. Business question: if you were the retention manager, which segment would you target first? We calculate churn rate within our custom multi-rule segments. This helps us prioritize interventions for segments with high churn. Running the cell now. This crosstab shows the proportion of customers who churn or stay within each segment, highlighting key differences in behavior. Notice how the at-risk new segment has a high churn rate, 52%, while loyal long-term customers rarely churn, 3%. This output helps illustrate how categorical segmentation can reveal meaningful patterns in customer retention, essential for building effective rule-based models. We create a synthetic Net Promoter Score survey dataset for analysis. Each row is one customer response, with demographic and region info. Score is from 0 to 10, a typical NPS format. We print dataset dimensions and preview a few rows. Running the cell now. The output shows that our dataset contains 500 customers, each represented by 4 columns: customer ID, age, region, and NPS_score. Notice the mix of numerical data, age, NPS_score, and categorical data, region, which highlights the need to handle each type appropriately when building rule-based segmentation. This step confirms we have a well-structured dataset to explore customer feedback and demographics before applying segmentation rules. Practice: think of at least one segmentation rule using NPS score. In business, segmenting customers by NPS score is common. Detractors 0 to 6 may hurt brand reputation, passives 7 to 8 are neutral, and promoters 9 to 10 actively promote. We define a function to label customers into these segments. Printing the count of each NPS segment helps set priorities. Running the cell now. This output shows the count of customers grouped by their NPS segments, detractor, passive, and promoter, based on their NPS score. Notice how most customers fall into the detractor category, highlighting potential areas for improvement. This segmentation step is key for rule-based analysis, turning raw numeric scores into meaningful categories for targeted actions. How many customers are promoters versus detractors? What is the business impact? We analyze how NPS segments distribute by region. This exposes key regional challenges or strengths for customer satisfaction. Running the cell now. This output shows the proportion of NPS segments, detractor, passive, and promoter, across different regions, normalized by each region's total. Notice how most regions have a majority of detractors, with the West having the highest share of promoters at 21%. This helps us understand regional customer sentiment before applying any rule-based segmentation. We save a summary table of customer NPS segments per region to a CSV file. This is typical for sharing analysis with colleagues or management. A message is printed to confirm the save. Running the cell now. This output confirms that the code successfully grouped customers by both region and NPS_ segment, counted their occurrences, and saved a clean summary table without missing values. Notice how organizing the data this way helps us understand the distribution of customer sentiment across different regions, an essential step before defining any segmentation rules. This summary file allows for easy exploration and ensures no data gaps interfere with rule creation. Now opening the NPS segmentation summary file so you can review customer groups per region. Data quality is crucial for segmentation rules to work. We check for missing values that can break rule logic. Print counts of missing values by column to inform cleaning. Running the cell now. This output reveals that the description and customer ID columns have a significant number of missing values, with customer ID missing over 135,000 entries. Noticing these gaps is crucial because missing data can affect how we define and apply segmentation rules, especially for key identifiers or textual responses. Before building any rules, this step highlights the need to decide how to handle or impute these missing values to avoid incorrect analysis. Tip: missing customer IDs make segmenting impossible. Always check. Typos in column names often cause failed groupings. The code attempts to group by a mistyped column and catches any error. When an error occurs, it prints the problem and suggests the fix. Always double-check your column names before Group B or rules. Running the cell now. This output highlights a common beginner mistake, referencing a column name that doesn't exist due to a typo, value segment instead of value segment. It reminds us to carefully check column names before grouping data by customer segments, as accurate column references are crucial for correctly counting unique customers and understanding segment distributions in the data. Sometimes survey data can have missing or out-of-range values. We improve our function to label such cases as unknown for safety. Counts help ensure our segmentation is robust even if future data are messy. Running the cell now. This output shows the count of customers in each NPS segment after applying a safe segmentation function that handles missing or invalid scores by labeling them unknown. Notice how the majority fall into the detractor category, indicating a trend toward lower satisfaction in this dataset. This step emphasizes the importance of correctly categorizing and cleaning your data before using it for rule-based segmentation. Practice: add similar checks to rules in your own projects. Cross-tabulating segments reveals how segments overlap and where to focus. Here we summarize how tenure and contract type categories combine. Running the cell now. This table shows the count of customers in each contract type segmented by their satisfaction group, highlighting how established customers tend to have longer contracts, while the new customers mostly have month-to-month plans. Notice the clear difference in distribution across segments and contract types, which is crucial for designing targeted segmentation rules based on customer behavior. This crosstab helps us understand the relationship between categorical features before formalizing the segmentation logic. Pattern crosstab analysis is a classic segmentation technique in market research. Indexes score customers on criteria like loyalty or risk. We create a simple loyalty index. Tenure is multiplied by 1 for 2-year contracts, 0 otherwise. Running the cell now. This output shows the first 6 rows of the data frame with tenure, contract type, and the newly created loyalty index column. Notice how loyalty index is 0 for all these examples because none have a 2-year contract, illustrating how the code combines numerical and categorical data to create a rule-based feature. This step highlights the importance of correctly handling categorical comparisons and the role of feature engineering in segmentation. Practice: think about how you could build a risk or value index for another dataset. Analyzing segment trends over time gives key business insight. We add a month column and count unique customers per month. Printing recent months shows if customer numbers are rising or falling. Running the cell now. The output shows the number of unique customers each month over the last year of data, ranging from about 680 to 1,700 customers. Notice the seasonal trend with spikes in September, October, and November, reflecting possibly higher customer engagement or sales during those months. This step helps us understand customer activity patterns before applying rule-based segmentation, ensuring we consider timing and customer frequency in our analysis. Let us put it all together: segment users, analyze churn, make a market recommendation. We count the sizes of each segment. We get the churn rate for at-risk new users. If churn is above 30%, we recommend a targeted action. All results and recommendations are printed for the business team. Running the cell now. This output shows the count of customers in each segment, highlighting that the largest group is Other, followed by At-Risk New and Loyal Long-Term. The churn rate for At-Risk New is over 50%, which exceeds the 30% threshold set in the code, triggering a recommendation to focus retention efforts on this group. This demonstrates how exploratory segmentation and churn metrics guide targeted business actions. You have now completed a real-world segmentation analysis recommendation pipeline. Want to advance faster? Subscribe to our channel and try designing your own business segmentation in a new notebook.